name is Amanda Bennett. I'm with Ohio State University Extension in Miami County, where I'm the Agriculture and Natural Resource Educator. I am here to talk to you today about conserving native bee populations for pollination. I'm a beekeeper and I grew up on a farm, so I'm really interested in the interaction between what we do in farming and conserving native bees and how we can do that and maximize pollination. So today we're going to talk about the diversity of native bees, factors that might affect that pollination that they provide, and ways that we can optimize that pollination and protect those pollinators at the same time. There are about 4,000 native bees in the United States and many lookalikes. Not all of them are native to Ohio, but many of them are. This will not include the honeybees because they are not native to the United States. Wild bees have an advantage that they can, wild or native bees have the advantage that they can fly in early spring and are better adapted to flying in poor weather conditions than most other bees. They visit flowers and pollinate in cool, cloudy conditions when honeybees are less active. So in warm, sunny weather, wild bees are often begin foraging earlier in the day and fly later into the afternoon. So our ability to support a diversity of bees has advantages over relying over a single species to provide stable pollination. So if bee diversity is high in an orchard, for example, populations of one or several species, if they might fluctuate due to maybe parasites or disease, we can still have that stable population because we have that diversity. So until recently, honeybees have been so easy to manage that little attention had been turned to native bees and their pollinating abilities, but interest is high now that we have some problems with managing honeybees due to weather and disease and pest problems. So we're going to look at each bee family that's common to Ohio backyards, and members of these families can be seen in virtually every backyard in Ohio. Many of these are ground nesters and many of these are specialists. So we're going to take a look at a few of the common ones. It's important for producers and homeowners alike to be aware of the diversity of species and their habitats so we can know how to protect them and how to encourage them in our crops and in our landscapes. First, we'll take some characteristics of native bees, take a look at those. They're generally solitary bees, although they might live in aggregates where they work near each other, but they do their own work. So each female is responsible for building her own nest. She lays her own eggs, of course, and gathers all the pollen for those developing larvae. She usually completes her life cycle before her offspring emerge in the spring. So they're generally a lot shorter lived in comparison to some non-natives that we'll discuss later. They tend to fly for just about 5 or 8 weeks of the year. So the bees that you see in the spring are generally not the ones that you see in the fall. There are a lot of specialist pollinators in the native bee category. They collect pollen from one species, from one genus or one family of plants. The example at the top here on the squash flower is a squash bee, of course, that lives at the base of squash plants and it only pollinates squash and pumpkins. Most native bees are ground nesting. We can see some examples here in the picture. The brown kind of example is how it might look underneath the ground with a main tunnel and then branched rooms that hold some pollen and an egg or developing larvae. You can kind of picture it like a clump of grapes. That's how it might look underneath. So native bees, in addition to those that are ground nesting, they might have cavity nesters or might be considered a cavity nester. These bees live in pithy stemmed plants, such as plants in the members of the mint family or maybe some wood that had been tunneled by another insect. The queen places her pollen and she deposits an egg onto it and then closes it off with a little partition and then repeats that process. Some bees in the leafcutter family might even take a portion of a leaf and line the cavity with it. Roses in particular are a favorite for this category of bees. So you might see some damage to your roses, although I have seen damage like this on a maple tree as well. Native bees are used for pollination, but they're not necessarily domesticated. One example might be that fruit growers tend to utilize the blue mason bee to pollinate particularly apple crops. You can use artificial structures like the one pictured here on the screen to attract them and house them. These native bees emerge in the early spring and they mate, and then they search for empty holes and begin to do their work in stocking their nests. Their preferred food is fruit pollen, and they use it like any other cavity nesters, as I explained before. Their affinity for kind of erecting those clay partitions between the eggs is this kind of mud building behavior is how they got their name, their common name, mason bees. But they kind of come out in the early spring and then are complete their life cycle and then kind of overwinter as almost adults. And so for this reason, you can kind of semi-domesticate them. Sometimes orchard growers will have boxes out like this, something like this, and then they'll take them in kind of in the early fall, store them in a cool, dry, dark place, and then bring them out in the next spring. And when temperatures begin to warm up, so they're right there at their orchard and can start to emerge and then have the life cycle all over again. So just to kind of recap, in early spring, those bees emerge. Usually the males emerge first in most of these species. During the spring, the females are mating and foraging and building nests. By the summertime, those adults die off and the larvae develop. And then the winter time is usually spent as those bees are kind of almost adults, kind of pupating until they can arrive at early spring again and emerge. We'll take a look at a couple of the bee families. The first one is the Andrenidae family. This is ones that kind of emerge in the spring. There are a few of these that are fall flyers. Most of these are specialists though, and they're all ground nesters. For that reason, some of their common names are the miner bees or sand bees, because they're kind of particularly drawn to the south-facing kind of areas that might have some sandy soil. Another common one is Perdita, as pictured with the quarter there on the middle of the screen. They're the smallest. Perdita minima is the smallest in this family. And because these species are really small, their ground nests are very shallow. So particularly tillage is a problem with these. This might be the first bee that you see in the spring. And usually the males kind of alternate between feeding on flower nectar and waiting for females to emerge so they can mate. You might see a mound of soil with a hole in the center, and that might indicate that the females are constructing their ground nest below. These are some that might live in large aggregations, so that kind of living together but doing their own work. Again, they're still solitary. Another common genre is the Anthidium, this Anthidium of the Megachilidae family. Most of these are summer flying bees, and they're often referred to as wool carder bees because of their habit. They kind of scrape the kind of fuzzy, the wool off those fuzzy flowers and then use it to pad the inside of their nests. In this bottom photo, you can see a wool carder bee doing what it does, scraping the fuzz off of what it looks like to be lamb's ear and balling it up to take back to the nest for padding. Another species that might be more commonly known as the European wool carder bee, but this is actually an invasive species from Europe. They're fairly big and easy to see. These males are highly aggressive and they defend flowering plants from other pollinators and insects. In fact, they have these kind of projections on their abdomen, and they kind of do battle with other bees, including honeybees. And they've been here since the 1960s. So they've been around for a while. Most of the species in this family, though, are moderately hairy, especially the abdomens of the females, so they're very easy to kind of identify the females from the males. That thick coating of hair on their abdomens really helps them gather pollen. Some of these they nest in the ground, but they also readily accept those wooden bee nesting houses, so if you're wanting to attract those, that might be a good possibility. Another bee family is the Halictidae family, and it has many species in this family. There's a lot of ambiguity with the number of species because they generally look very similar and it is hard for identification. This family includes the sweat bees. They are all generalists and they do live in the ground. A couple of them live in aggregations, so they're somewhat semi-social. Semi-social can mean that a female may kind of bully or convince her sisters to perform nest duties while she stays home and lays eggs. So sometimes we see that kind of behavior. These are commonly called sweat bees because they have an attraction to sweat. They're very small and slender, and some species are metallic green, but most of them are black or brown. They nest in the soil or rotted wood. Some of these are solitary, like I said, while others are not. They are generally found feeding at composite flowers with the center of tiny tiny true flowers surrounded by kind of rays. Think of kind of like a black-eyed Susan during the midsummer, or maybe asters during late summer or early fall. One of these species is the green metallic sweat bee. You can see here on the left. These bees are examples of ones that lived in the ground, who sometimes live in aggregations, and they not only live in aggregations with other green metallic sweat bees, but they can often be seen with other bees like mason bees. The one here in the bottom is the true sweat bee. It's actually a little bit smaller and shinier than this halictus sweat bee, which is a little bit truer dark black with a little bit of white bands on it. The largest bee family is excuse me, is Epidae. It includes, from the top to left, it includes the carpenter bee, the squash bee, digger bee, longhorn bee, and the cactus bee, among others. And it also includes the honeybee. And since it's the largest family of bees, I'll just highlight a couple of them. One of the ones we're familiar with is the bumblebee. These are social bees. They live in the same family, and they're in the same family as honeybees. The bees collect pollen similar to honeybees, and they have different castes. They have a queen, they have workers, the other females, but they don't lay eggs, and then they have the males. Bumblebees are really furry and they're not specialists. They do live in the ground though, which I think most people might not know. They live in maybe abandoned rodent nests or undisturbed meadows or pastures. They might take up a bird's nest or a rock wall. They might even be taken to insulation in walls or rugs that might be stored in sheds. So you can see a picture here at the bottom of a kind of an opening of a bumblebee nest in the ground. These are really have advantageous because they're active earlier and later in the year. They have a affinity for buzz pollination, so they can kind of move their wings and their bodies in a way that kind of shakes the flower, especially so if they're a deep flower, you can kind of shake it to achieve pollination or achieve what they want to do is collect pollen. They're really important for pollinating nightshade family and heath family crops, such as potatoes, tomatoes, blueberries, squash, melon, cranberries, things like that. And even in one study, cherry tomatoes, when we had these native bumblebees present, the yield tripled. So they are quite, they can be quite advantageous for producers. Another bee that we might be familiar with is the carpenter bee. These are the largest ones of this family. They nest, of course, in wood. They're not specialists. They have these galleys. This is kind of a cross section of what it might look like in probably your shed or something like that. They're often a nuisance, but they're not harmless. The ones that we see kind of outside buzzing us are generally the males that are being protective of their nest and their queen, but those do not have stingers, so they are relatively harmless. Carpenter bees are generally seen in the spring. They don't always play nice because they tend to be nectar robbers. You'll see some damage here. The slit at the bottom of the flower of the blueberry crop pictured there is damage from a carpenter bee that can eventually look like the picture there on the left. Of course, to increase pollination in our crops, we might have bring in a non-native, such as the honeybee, the Apis mellifera. They're native to Europe and Western Asia and parts of Africa. They're different because they're social insects. They all work together. They have large hives. They overwinter as a cluster and eat honey in the winter. The picture there on the right is what a cluster might look like in the middle of the winter. Bee colonies are moved extensively across the country for use in multiple crops every year. We also have some factors that might affect pollination as well. Temperature affects it. Any temperatures below 60 degrees reduces bee activity, and likewise temperatures above 85 or 90 kind of slows down their activity as well. They don't really like wind. Rain will certainly be taking cover just like anybody else. Humidity, like I said, kind of the hot weather actually doesn't affect bee activity exactly, but the combination of the temperature and humidity is important for the ripening of the anthers of the flowers, and so therefore the pollen availability is decreased, so they won't get as much when they're trying to go and forage. Wind, they don't like wind, and even some cloud cover can really reduce their interest in foraging and reduce pollination at that time. So also plant factors can affect pollination. I just described how the anthers you know, are not fit for really producing that pollen or being able to release that pollen when the humidity is too high. We also have a sugar concentration issue. The higher the sugar concentration, the more attractive to the bees. So higher temperatures, not extreme, but higher temperatures and relatively low humidities with a little bit of air movement are all conducive to higher sugar content. So we'll see more bees foraging at that time. So what can we do to optimize the pollination on our own crops? We can hire honeybees, of course. I know they're non-natives, and this presentation is focused on natives, but that is a possibility. You need to get with beekeepers early, need to have an understanding on what they might do as far as pest control practices, how they're going to kind of manage their hives, need to kind of think about placement, draw up a contract, make sure you have an adequate number of colonies and that you're obtaining them at the proper time when you might need them, and have a strategy for how you're going to place them for maximum effect. Honeybees need warm, sunny areas, and you need to provide fresh water. And there's some examples right there of how to accommodate them. When are you going to place them? Timing is critical depending upon what kind of crop you're growing. So we see some examples there of how it kind of varies between apples and sweet cherries. Placement, they work very close to their hive, a half a mile. So you kind of want to think about that. Want to think about how you might distribute them evenly or clusters, and you really would work with your beekeeper on that if you are not the beekeeper. There's a formula for determining the field force of a hive. So kind of like the strength of a hive, not every hive is the same. You might have some reduced foraging ability for a hive for whatever reason, but you need to know what they might do and how many you might have. So we would need to kind of observe these numbers of bees to know whether or not we have the proper amount of bees active. And when you're doing this, you can not only do honeybees, but you can do other bees as well if you're kind of thinking about what your pollination might look like. We have some of those colonies can vary from, like I said, 3,000 to 40,000. So you're going to want to work with your beekeeper on these things. Strawberry pollination, just kind of looking at a couple different crops here. Strawberries, we see some of those mining and sweat bees and ground nesters that are working on strawberry plants. Cherries might be similarly visited by mining bees or sweat bees or bumblebees, and of course honeybees are favorite of those. Apple pollination, probably the one that we're most familiar with in Ohio. A lot of managed honeybees are commonplace in those orchards, but we have studies that show natives can really outnumber them in orchards. And natives not only outnumber them, but they deposit more pollen per visit than honeybees. So honeybees are probably, might not exactly be the answer to your pollination problems. Squash pollination, remember that those are generally pollinated by specialists, those squash bee specialists, and they live in the ground. So tillage is kind of an issue with squash. Also rotation. Of course, we know that rotation is popular, or not popular, but it's important for disease prevention and insect prevention, but it also, we got to think about also pollinators. So they kind of need to be close. If you are looking to put honeybees on squash, you can. Up to three honeybee hives per acre is kind of an average. Providing some early spring or summer flowers nearby can be helpful to attract natives as well, and then avoiding that really deep, frequent tillage. Watermelons is another important crop that are usually attractive to bees because of their concentrated nectar in their flowers, but they have fewer flowers, so competition kind of decreases pollination abilities as those bees kind of compete for resources. Cane fruits, to encourage pollination, you might retain some natural habitat around the field, rodent nests, dead wood to attract some of those native bees, and also might be adding additional flowering species to support those wild bees around those areas. So how can you build native populations? First, you need to provide a diversity of food species around your orchard or wherever you're growing. provide perhaps a habitat, depending upon which one you're trying to, an artificial house, depending upon which one you're trying to attract. Areas of bare soil can really help those ground nesters and those pithy stems. If you think about the weeds or things like that, that might be attractive to those cavity nesters. And then minimizing tillage can also help because we know that many are ground nesters. So how can we protect them? We know that particularly in fruit and vegetable production, we have insecticides being applied. They could probably harm, they could harm pollinators in a variety of ways. So we need to be cognizant of that. If we're talking about agronomic crops, there are some products that are used that have the potential to impact native bee populations in a negative way. Luckily, we can utilize some strategies as fruit and vegetable production can and agronomic crops to minimize that interaction. We can think about the time of day that we apply pesticides. Delaying a pesticide application is one way to reduce that risk of exposure. So either early morning or early evening is the best time to apply those pesticides with limited interaction with native bees. Mowing ground cover before you spray, particularly in orchards, or if you're using on your lawn, or if you're if you have attractive species in like ditches or waterways that might be attractive to native bees, and you're going to do a pesticide application, one way we can reduce the risk is remove the most blooms as possible. So remove blooms in those grassy areas. So mowing that can help reduce the risk. Know that formulations matter. So things like dusts and wettable powders, those are the most dangerous to pollinators. Things like granulars or seed coatings are less dangerous as you kind of like look at that chart and move down. Reading the label, of course, is important. Many of them have bee implications right there on the label, and of course, whatever it's going to be harmful for the honeybee is also going to be harmful for other native bees as well. So we can use that strategy similarly. Organic does not mean safe. Keep that in mind. I've listed a couple here that are approved organic pesticides, but they're not safe for bees. However, if they're allowed to dry, the risk decreases. So for the same reason, you can apply these either in the morning or the late evening, or sorry, the early evening, and allow them to dry all night, and that can help reduce the risk to pollinators. These are okay when they're applied directly, or when they're not applied directly to bees, and they have to be applied to non-blooming crops or in the evenings or night, like I said. Avoiding spraying flowers with fungicide is really important. Bees rely on a fermentation process to turn pollen into bee bread, which is the food for their young. So in the landscape, we're talking about homeowner landscape, you know, we need to be really reserved with spraying fungicides for aesthetic reasons to minimize interactions with those native bee populations and non-native bees like honeybees. Most fungicides on landscape plants do not kill the plant, but they make it, I'm sorry, most fungus on landscape type plants, they don't kill the plant, but they make it kind of look bad. So we want to think about what the risk and the reward is. So maybe at the very least spray it when the plant is not in bloom. Be cautious of tank mixing. This is mostly for large operations. They utilize what is known as tank mixing in order to minimize the amount of trips across the field to reduce compaction, reduce labor and fuel costs as well. So it might be a herbicide with either a fungicide or insecticide. Just know that some of those mixes can make the mix actually more toxic to bees. On the home front, if we're talking about mixing, just make sure you're not overdosing. You're following the label. If you're using a concentrated type product that you mix with water, more is not better. Please follow the instructions on the label to a T. Avoiding drift, so making sure that we're not drifting on non-targets. You can see here in the example, it's kind of like everywhere a little bit. But if we can still minimize this, it does look like the alleyways had already been mowed, so we're reducing the blooms there. So we can do things that will help minimize the risk. Know that residual toxicity, we have low temperatures. If we have low temperatures and dew, that can delay the absorption of the pesticide into the plant, and therefore make it available to be less toxic, or be more toxic, it remains on the plant. But in general, the longer the product remains on the plant, the less harmful it is to pollinators and native bees as well. So to conserve in the landscape, we're thinking about food, water, cover and shelter, and a place to raise their young, as I just described what their habitat was. So if this was kind of like the perfect ideal farm, we might have hedgerows and windbreaks in order to provide overwintering sites for those, and that need to burrow into the ground and complete their life cycle that way. Also provides protection for them as well. And when wind breaks, we just described how they don't like to really fly in the wind. Of course, they're very small insects. We might have riparian buffers. So putting some plants and vegetation near water can kind of help with increasing native bee populations. Using artificial nests to attract those native bees might be a good way to increase those bees in your landscape. Having natural or undeveloped areas, remember many of these are ground nesting, solitary bees, so they need access to bare, sandy soil, areas without a lot of mulch, without landscape fabric, without plastic. We can also reduce the tillage in order to help them pollinate, be available to pollinate your crops. We might keep snags, keeping dead trees or standing trees provides shelter for native bees, of course, if it's not in an area that's going to be harmful. About 30% of native species use those hollow plant stems or old beetle boreholes, pithy stem plants like box elder or sumac, sunflower, blackberries, brush piles. All these are utilized by those cavity nesters. Leave areas next to fields untilled or unsprayed to support flowering plants and provide nesting sites for those ground nesting bees. You might use a cover crop, not only in your field, but maybe even in your garden can have an impact. And they do have cover crops that mixes that are specially designed for pollinators to supply pollen and nectar. If you create a pond or a ditch, leave that pile of excavated soil. Ground nesting bees can utilize that. You might plant clumps of native flowers to attract more pollinators to that area. Of course, your garden is a great way to attract native bees as well. Minimizing the tillage in your garden can really help to the extent possible to really attract those native bees as well. So in summary, there are a lot of native bees in Ohio, more than you probably thought to begin with, several hundred native bees. By following labels and best management practices, we can really ensure that they stay safe and healthy, have a place to have a habitat, have safe food to eat, and access to fresh water. And we can all really make an impact in where we live. There are some resources for attracting pollinators to the garden. We have a fact sheet on Ohio Line. We also have a great one about trees. People often don't think about trees as a pollinator food. And there is a great resource that is done by several universities, but housed there at the Michigan State address right there on increasing pollinators in your landscape. So I hope you've got some great information on how you can apply some of these practices and best management practices to your own operation in order to conserve native bees that are available for your pollination needs. My contact information is right there, and I hope that you enjoyed this presentation and can apply it to your operation. Thanks.